Hello everyone, I'm Aaron from DataStax, and today I'm going to take you through advanced Cassandra operations using Kubectl and Flux. So for the beginning here, I'm going to be bouncing around a couple of different instances of DataStax mission control. So I'm going to start with the one that's in our dev playground area over on Google, where in my project, my coworker Jeremy created a cluster, and I have this 6-node cluster called Permanent Waves. So if I go ahead and click into here, yep, you can see I have 2 data centers, 3 nodes in each. I think I've used this cluster before and kind of shown, videos on creating it and adding a new data center and whatnot. But what I want to show today is, real quick, there's a new feature we have. If I go to Modify Cluster, this new feature we have is to switch between simple mode and expert mode. So simple mode gives you this, web form UI. Switching to expert mode actually shows you like the Kubernetes manifest behind it. And you can actually go in and specify things that may not be in the web UI. So one thing that I want to demonstrate here is take this manifest YAML. By the way, I should mention this warning here that once you do modify something in expert mode, you can no longer modify the cluster in simple mode. They will actually prevent you from going to the simple tab. So it's important to note that. What I'm going to do is go ahead and paste that into a new document. Next is actually move that into my other mission control cluster that I have running out on Amazon EKS. As you can see here, we just have one cluster, roll the bones. But what if I want to bring permanent waves into this project? Let's go ahead and do that. First of all, get rid of the resource version line, because that's just really going to throw things off as you go forward. Next, we want to make sure that we update the namespace properly. Now, I use Aaron's Proj as a project name in both of these mission control clusters. But what I'm going to want to do is make sure that I have my exact unique slug on the end there. So if I say kube control get namespaces, and it brings back, oh, look at that, Aaron's Proj, just like that. Actually, really all I need is just that unique slug on the end. So let's do that. And paste. Okay, boom, there we go. Okay, now as we go through, we can see that we're setting a heap size of 4 gigabytes here with G1GC for the first garbage collector. We're having a data center name of Entre and yeah, rack name of R30, 3 nodes in that data center. And then another data center named Jacob's Ladder. So I just really want the one data center here for now. So let's actually pull this out of here. Just like that. All right. So we're going to end up with 1 CPU. We're going to end up with 4 gigs of RAM, 8 gigs of RAM, 4 gigs on the heap. Storage of 10 gigs. Yeah, let's bump that to maybe 20. We're not going to have a backup configuration. So let's just get rid of that whole line with Medusa right there. And of course, we have our Permanent Waves super user. The thing is, though, is that in here, we don't really have a way to specify a password. So one's going to be auto-generated for us that we will actually need to go in and pull out of there. Okay, I think this is sufficient here. So let me save this. Let's just call this PWEKS3. And I want to say .yaml, just like that. Okay, let's do a save. Oh yes, and of course, don't forget to update the storage class. So if I do a kubectl get storage class, there you can see I have a GP2 and GP3 defined. But if I go here, you'll notice that the storage class from Google I was using is standard, And the ones in Amazon are GP2 and GP3 that I have here. So I'm going to change this to GP3, just like that. And we're going to save that. Kube control apply -F local permanent waves EKS3 YAML. So I run that command. We can come back to mission control here. And boom, just like that. We get permanent waves, 0 nodes up, 3 down. Okay, you can see that our first node here, permanent waves entre new R30 STS0, actually has 1 out of 2 containers running. And the other 2 nodes are now in an init state. Hopefully things will progress real quickly here. There we go. There, you know what? Let's just do a grep permanent waves just so that we can only see the pods that relate to our current Cassandra cluster that we're trying to build. Or in this case, HCD cluster that we're trying to build. All right, so if we circle back to mission control, hey, you can see that these actually do have IP addresses. All right, they are definitely on their way up. Looks like everything is good to go here. So yeah, we've just taken a cluster's manifest YAML from one mission control and successfully run that YAML and, recreated that cluster inside of another mission control from one cloud to another. So let's go ahead and use this. We can go to the CQL console here, and it asks for a user, but we don't know what our username and password is just yet. Well, actually, we do know the username. It's permanent wave super user, but the password in this case would have been auto-generated. So let's go ahead and get that. So we can do a kube control get secrets permanent waves super user. And we want the namespace, of course, Aaron's Garage, and then our unique slug 5HC6UEXB. And we want that output as YAML. Here we have our 64-bit encoded username and password. What I'm going to do is let's copy this line here just to make sure that it works the way we think it does. And we can say echo and then paste that. And then we're going to pipe that to base 64-D. And this should come back. Yep, there it is. Permanent wave super user. Perfect. Now for the password, we're going to do the same thing. We're going to say echo. We're going to copy that base 64 encoded string right there, paste that in, and pipe that to base 64-D. There is our password, just like that. Now I can go back up to here and say permanent waves super user, and then paste my password, and we're in. Look at that. Outstanding. Next, let's say that we want to be able to access this cluster using the data API. What I'm going to do is create a load balancer that will allow us to access our cluster via that data API. So let's go ahead and do a kube control get services, and we'll have our namespace on there as well. And let's also do a grep permanent waves. Okay, so our data API service is right here. So now let's do a kube control expose service. I'm going to paste that in. We want to expose it as a type load balancer name, same name, just with an LB on the end. And let's make sure that our namespace is on there. Port 8181. 8181. Now, if we go ahead and say get services again, we ought to be able to see the load balancer that we just created, and it'll have this DNS entry that we can copy. Now, if I wanted to use something like Postman to access this cluster, I can go ahead and, I can paste that in. In the headers, I'm going to want to make sure that I have my Cassandra token in here. And if you remember from some of the other videos, your Cassandra token is the word Cassandra, and then a colon, and then the 64-bit encoded username and password, which we just saw via this get secrets kubectl command. So let me grab the username and paste that, and then type a colon, and then grab the password, and then paste that, and we should be okay. So now, if I go back to the body, we're going to do a create namespace. We want it to be named default namespace, network topology strategy 3. Let's do that. Oh, we want to make sure that these match our data center names. So the name of our data center is Entre-Nous. So let's grab that and replace that. There we go. Now our data center name, we're saying we want 3 replicas for that namespace. So now let's try that. Hey, there we go. Status okay. All right. So now, if I grab my password here again, and I go back to the CQL console, I should be able to say permanent waves super user, and paste the password, and we're in, and now I should be able to use that default namespace, and boom, there we are. Describe key space. Of course, under the hood, this is, a data API namespace is a Cassandra key space, so this is how you'll see it defined underneath there. Notice Entre-Nous as our data center name and our replication. So yeah, this is all good. So now let's say that we want to make a change to our cluster. Maybe I want this to be automatic. What if I use something like Flux? Flux is a GitOps package that allows you to perform operations on your cluster while having that cluster definition versioned inside of a GitHub for source control. Pretty slick, if you ask me. One of the things is that you have to have Flux installed locally, and I've already done that. And just to make sure that we're all installed okay, I can do a Flux check pre. There we go. Okay, it figures out that we have Kubernetes going. Pre-flight checks are good. One thing that we're going to need to do is, first of all, create a GitHub repository. We're also going to want to make sure that we have an access token created for that repository. And if I go down to settings here, and in my own profile here, I can go to developer settings and personal tokens and fine-grained tokens. You can see that I have, in fact, created one for Flux here. Okay, and you can see that when I go ahead and look at the token settings, I can't actually see what the token is here once I've created it. But you can see that I've pointed it at this AWS EKS3 Flux repository, and it has access, with my user. And those actually need to be environment variables that you have set, while you're using Flux, is your Git user and your Git token. The next thing you'll need to do to get this to work is to run a Flux bootstrap command. I'm not going to rerun this again because I've already run it once, but the idea is it's a Flux bootstrap GitHub. Then you set your user as the owner, and remember that's an environment variable. You set the repository of, the same one that you pointed the token to. So in my case, AWS EKS3 Flux, branch main. Path is going to be clusters, Aaron's EKS3. It's going to use a personal token, and we want to set for token auth so that we don't have to type it out on the command line. All right, but this has already been done. Real quick, why don't I do a kubectl get namespaces? And if you look in the namespaces here, you can see we have this one called Flux System. So now if I say kubectl get pods namespace Flux System, you can see that by running that bootstrap command, that it has actually added the namespace and these pods out to my Kubernetes cluster, which of course is running in US West 2 of Amazon EKS. So what this is going to let us do is work with this directory structure that it puts in there too. So, I can cd into my clusters. You can see, yep, we have Aaron's EKS3. So we look in there. There's the Flux system, and there's my project as well. So let's go ahead and get in there. Inside my project, though, there isn't anything. So let's go ahead and move our file in there. Let's say we're going to copy from local pw EKS3 YAML, and I want to copy that right here. Go ahead and look. Sure enough, there it is. So let's go ahead and do a git add dot, and then git status. Okay, excellent. There's our new cluster definition. Git commit adding permanent waves cluster. All right, and then we can say git push origin main. Okay. Now, if I go and have a look at my repositories, we have a look out here, Aaron's EKS3, have a look at the project, and bam, here we are, just like that. So now let's say that we want to make a change here. So let's go ahead and say git checkout for nodes. All right, let's go ahead and do a VI on our YAML file here. Let's go ahead and page down to our Entrenu data center. And you'll notice we have a cluster size or a data center size of 3 nodes. Well, I'm going to update that to 4 nodes, just like that. And then we'll do a right quit. And then we can do a git status. Yep, git add. There we go. Git commit. Adding another node. We're going to say git push origin, and then our branch's name is 4 nodes. What I'm going to do now is go open a pull request. So let's go ahead and do a new pull request. We want to go from 4 nodes into main, and yep, you can see in our git diff here that we have a size of 4, replacing that line that has a size of 3 inside our YAML. And yeah, we can create that pull request, adding another node. Let's go ahead and create. Now let's merge this pull request and see what happens. And I will confirm. Okay, with that, we've merged in our YAML. Oh, and look, just like that, we have a 4th node that has popped in. So it took about a minute after that command ran for Flux to pick it up and to recognize that there were changes inside the cluster and to go ahead and to start building out that node. And oh, sure enough, look at that. It has an IP address already. It's in a state of starting. We can go here to our kubectl get pods command. And again, let's just grep permanent waves. Hey, there we go. Look at that. Permanent waves Entrenu R30 STS3 already has 1 of 2 containers running. It is on its way up. Oh, and there we go. We have 2 out of 2 containers running on node 3. If I go back and have a look at mission control, look, just like that, we have added a 4th node into our cluster. So hey, in this video, we've gone ahead and really just used mission control as a way to view our changes and view how our cluster reacts to what we run on the command line. So we've run a kubectl apply to build a cluster, just using a manifest YAML from a completely different cluster. we've gone ahead and, retrieved the password, and we've used that password once we've also exposed the data API service. We used that password to create a token that allowed us to go ahead and access it with the data API. We could create a new namespace, which of course is a key space in Cassandra. And then we just did a real quick introduction into Flux and GitOps and how to go ahead and essentially version your cluster definition inside of Git. Seriously, I think this is all pretty cool. So yeah, that should do it. For more information on DataStax Mission Control, just head on out to datastax.com/products/mission control. There you can find all the information you need, including downloads and documentation. Thank you and have a great day.